Mount Kupreanof. No recorded eruption in human history. Volcanic alert level yellow. As of May 12th of this year. The nearest functioning real-time seismometer the United States Geological Survey can use to monitor what is happening underneath this active American volcano sits 17 miles east of the summit, and it is attached to a completely different mountain. The Alaska Volcano Observatory, the federal agency responsible for monitoring all volcanic activity in the state of Alaska, raised Mount Kupreanof's threat level 3 days ago. The reason was not theoretical. Seismic activity beneath the volcano was first detected in February of this year. The largest of those earthquakes reached a magnitude of 3.1. Beginning on April 4th, satellite instruments operated by the National Oceanic and Atmospheric Administration began detecting sulfur dioxide gas emissions from the summit at concentrations of approximately 100 to 1,000 tons per day. The background emission rate for an inactive volcano is below 100 tons per day. The numbers crossed the threshold, and the threat level rose. But here is what almost nobody outside the small community of Alaska seismologists is aware of. Mount Kupreanof has been classified as inactive for the entire duration of recorded Western scientific observation in the Alaska Peninsula. There is no entry in the Smithsonian Institution's Global Volcanism Program database for any eruption at Mount Kupreanof at any point in the past 10,000 years. The mountain has been a quiet, ice-capped 6,000-foot stratovolcano on the southern flank of the Alaska Peninsula for as long as anyone has been keeping records. Until this year. What is happening at Mount Kupreanof right now is a magmatic intrusion. The Alaska Volcano Observatory, in its May 12th public notice, stated explicitly that the seismic and gas signatures are consistent with new magma moving upward into the volcano's plumbing system. The magma is not at the surface. The volcano is not erupting. But the magma is moving. The federal monitoring infrastructure positioned to track what happens next consists of one seismometer network 17 miles east of the volcano, 2 passes per day of polar orbiting weather satellites that can image the sulfur dioxide plume from space, and occasional visual reports from commercial pilots and fishing vessels that happen to be in visual range of the summit on clear days. This is not the level of monitoring the public assumes the United States has on its active volcanoes. It is the level of monitoring the United States actually has, and the federal government has been candid about why. The Aleutian Volcanic Arc is the longest continuous chain of volcanoes in North America. It stretches approximately 1,500 miles from the southern tip of the Alaska Peninsula westward into the Bering Sea and southern Russia. Within the United States section of the arc, the Smithsonian Institution counts approximately 80 volcanoes that have been classified as historically active. The state of Alaska contains, by every published federal count, more historically active volcanoes than the rest of the United States combined. Mount St. Helens, Mount Hood, Mount Shasta, and Lassen Peak, the famous lower 48 volcanoes that dominate the public imagination of American volcanic risk, are a small fraction of the total American volcanic inventory. The Aleutian Arc is the rest of it, and the Aleutian Arc is overwhelmingly under-monitored. The reasons are remote geography and budgetary constraint. The Aleutian Arc runs through some of the most remote terrain in the United States. There are no roads connecting most of the volcanic peaks to the Alaska State Highway System. Mount Kupreanof itself is approximately 50 miles by floatplane from the nearest community, the town of Cold Bay on the southern Alaska Peninsula, which has a population of approximately 78 residents and a single airport. The other settlements in plausible visual range of the volcano are King Salmon, Sandpoint, and Port Hayden, all of which have populations under 500. The infrastructure required to install and maintain real-time seismic monitoring equipment on a remote Alaskan stratovolcano is not trivial. The Federal Volcano Hazards Program operates on an annual budget that has not, in real inflation-adjusted terms, increased meaningfully since the program was established. But here is what makes this situation different from other domestic monitoring gaps. The Aleutian Arc sits directly underneath one of the busy international air routes in the world. The North Pacific Corridor, the Great Circle flight path that connects the United States West Coast to East Asia, passes within direct ashfall range of dozens of Alaska volcanoes every single day. Approximately 90,000 passenger flights per year route through this corridor, carrying between 15 million and 20 million passengers annually, depending on the year. Every one of those flights operates at altitudes between 30,000 and 40,000 feet, the same altitude range at which Alaskan volcanic ash plumes routinely reach during eruption events. The aviation risk is not theoretical. On December 15, 1989, a KLM Boeing 747-400 carrying 245 passengers and crew on KLM Flight 867 from Amsterdam to Anchorage flew into an ash plume from the Mount Redoubt volcano, approximately 150 miles east of Mount Kupreanof. All four of the aircraft's Pratt & Whitney engines flamed out within 60 seconds of the ash encounter. The aircraft descended approximately 14,000 feet in a powerless glide for 8 minutes before the crew was able to restart the engines and land safely in Anchorage. The cost of repairing the engine and airframe damage to that single aircraft was approximately $80 million in 1989, equivalent to over $200 million in current value. Nobody died. The incident did, however, change every safety protocol in the global aviation industry. The Anchorage Volcanic Ash Advisory Center, one of 9 such centers operating globally under the World Meteorological Organization, was established directly in response to the Redoubt incident in 1990. Its function is to issue real-time advisories to all aviation operators about active volcanic ash plumes in the Alaska region. The center now issues approximately 300 to 500 advisories per year, covering ongoing or potential ash events in the Aleutian Arc. The Redoubt incident was not the only major Alaska volcanic event in modern history with global consequences. On June 6, 1912, the Nova Rupta Katmai eruption on the Alaska Peninsula released approximately 13 cubic kilometers of volcanic material in 60 hours, making it the largest volcanic eruption anywhere on Earth during the entire 20th century. The ash plume reached the stratosphere and produced detectable global cooling effects for the following 3 years. The Nova Rupta site, located approximately 190 miles east of Mount Kupreanof, demonstrates the upper end of what Alaska Peninsula volcanism can produce. In August 2008, the Kasatochi volcano in the central Aleutian Islands erupted unexpectedly, sending an ash plume to 45,000 feet and disrupting trans-Pacific aviation for 4 days. The Kasatochi eruption produced almost no precursor warning. The Alaska Volcano Observatory had been monitoring it through satellite imagery only. The Anchorage Volcanic Ash Advisory Center is one of the most consequential federal aviation safety organizations in North America. Its operating mandate depends in part on having functional ground-based monitoring on Alaska volcanoes. For most of the 80 active volcanoes in the Aleutian Arc, that ground-based monitoring is either limited or non-existent. The center issues advisories using satellite imagery, lightning detection networks, pilot reports, and ground observations from the small number of fully instrumented volcanoes. Mount Kupreanof, before this year, was not on the priority instrumentation list. The volcano had never erupted in observed history. Federal investment was directed toward Mount Veniaminof, Mount Pavlov, Mount Shishaldin, Mount Cleveland, and other peaks with documented eruption histories. The seismometer network at Mount Veniaminof, located 17 miles east of Kupreanof, was installed to monitor that volcano. It is now the only real-time seismic instrument capable of detecting earthquakes at Mount Kupreanof. And here is what monitoring from 17 miles away actually tells you. The Veniaminof network can detect earthquakes of magnitude 2 and larger occurring beneath Kupreanof. It cannot detect the smaller harmonic tremor signatures that typically precede a major eruption by hours to days. It cannot triangulate the precise depth of seismic events occurring directly beneath the Kupreanof summit cone. It cannot resolve the difference between a tectonic earthquake unrelated to volcanic activity and a volcanic earthquake associated with rising magma. The Alaska Volcano Observatory's seismologists have, in informal communications with science journalists since May 12th, acknowledged that the precision required to forecast a Kupreanof eruption is not available at the current monitoring level. This is not a failure of the Alaska Volcano Observatory. It is a federal resource allocation issue. The agency monitors what it has been resourced to monitor. Right now, the Alaska Volcano Observatory is requesting emergency authorization to deploy portable seismic stations on or near Mount Kupreanof. The portable stations, mounted on tripods and powered by lithium battery packs, can be flown in by helicopter and installed within 48 to 72 hours of authorization. The installation cost is approximately $350,000 per station. The maintenance cost is approximately $200,000 per year per station, primarily for site visits, equipment replacement, and data transmission. A full monitoring network at Mount Kupreanof would consist of approximately 5 to 7 stations distributed around the summit cone. The total deployment cost would be approximately $2 to $2.5 million. The annual maintenance cost would run between $1 and $1.5 million. The Federal Volcano Hazards Program's entire annual operating budget for the Alaska Volcano Observatory is, by published federal figures, approximately $12 to $15 million per year across all of the 80 active Aleutian volcanoes the agency is responsible for monitoring. The math is not favorable. But here is the part that almost never reaches a general audience. Mount Kupreanof is not the only currently active Alaska volcano with monitoring gaps. As of mid-May 2026, the Alaska Volcano Observatory lists Great Sitkin at Volcano Alert Level Watch, with aviation color code orange, with slow lava effusion continuing in the summit crater since 2021. Shishaldin, which reaches 9,373 feet and last erupted in 2023, remains at advisory yellow, with ongoing seismic and infrasound signals plus sulfur dioxide and steam emissions visible from satellite. Pavlov, at 8,261 feet, has been at advisory, yellow continuously for over 2 years with periodic ash emissions. Veniaminof, at 8,225 feet and the host of the seismic network 17 miles east of Kupreanof, has erupted at least 35 times in the past 200 years. Cleveland in the Central Aleutians, at 5,675 feet, is one of the most consistently active volcanoes in the United States, with 22 confirmed eruptions since 2001 alone. On May 14th this year, 5 separate Alaska volcanoes were simultaneously in some elevated alert state, all of which require monitoring resources. None of those monitoring resources can be reduced to redirect attention to Kupreanof without creating a different monitoring gap somewhere else in the arc. The North Pacific aviation corridor that crosses this volcanic field carries approximately 20,000 cargo flights and 70,000 passenger flights per year, with total annual passengers crossing the Aleutian region estimated at 18 million. Major airlines operating regular service through the corridor include United Airlines, Delta Airlines, American Airlines, Alaska Airlines, Korean Air, Japan Airlines, All Nippon Airways, Cathay Pacific, and FedEx. The economic value of cargo moving across the corridor on any given day is, by Federal Aviation Administration estimates, approximately $1.5 billion in transit at any moment. The federal volcanic monitoring infrastructure in Alaska is, in the published assessment of the United States Geological Survey itself, operating at approximately 40% of the instrumentation density that would be considered standard for similar volcanic terrain in the lower 48 states. This is not a recent decline. This has been the operating state of Alaska volcano monitoring for the entire history of the Alaska Volcano Observatory, which was established in 1988, the year before the Redoubt KLM incident. The agency has made the case for additional federal funding in every appropriations cycle for 36 years. The funding has, in real terms, never materialized at the level the agency has requested. Mount Kupreanof is therefore not an isolated case. It is the latest illustration of a long-running structural reality. The United States operates a Pacific Ring of Fire volcanic arc that contains more active volcanoes than most countries on the planet have territorial volcanoes. The agency responsible for monitoring those volcanoes operates at less than half the instrumentation density that would be considered adequate. The monitoring gap is, by federal acknowledgement, not closable at current funding levels. And when a volcano with no recorded eruption history wakes up, as Mount Kupreanof has now done, the agency is forced to manage the response with a seismometer attached to the wrong mountain 17 miles away. The aviation routes continue to operate. Flights continue to cross the Aleutian Corridor. The Anchorage Volcanic Ash Advisory Center continues to issue advisories based on whatever data is available. The Alaska Volcano Observatory continues to track Mount Kupreanof through satellite passes that occur twice per day. Infrasound detections that confirm whether the volcano is generating audible pressure waves. Lightning network detections that would register if ash plumes generated electrical discharges, and visual reports from any pilot or mariner who happens to be in line of sight on a clear day. The volcano is not erupting. The volcano may not erupt at all. The current unrest may dissipate over the next several months as the magma intrusion stalls below the surface and the system returns to its previous quiet state. This is one of the more common outcomes for volcanoes that show signs of unrest without proceeding to eruption. The Alaska Volcano Observatory has been clear in its public communications that an eruption is not imminent, and that significant additional precursor activity would be expected before any eruption would occur. The yellow advisory is a recognition of unrest, not a prediction of disaster. The reflective question is what happens when a volcano with no monitoring infrastructure does proceed to eruption. Monitoring gaps matter because they shorten the available warning time. The answer, based on the historical pattern of Aleutian volcanic eruptions, is that the warning time available to civil aviation drops from days, which is what fully instrumented volcanoes provide, to hours or minutes, which is what satellite-only monitoring provides. The Anchorage Volcanic Ash Advisory Center can detect an ash plume after it has reached cruising altitude. The center cannot reliably predict it before it occurs. Flights operating in the Aleutian Corridor at the moment of any future Kupreanof eruption would, in the worst case, learn about the ash plume from satellite imagery rather than from ground-based eruption forecasting. The flight corridor is wide. The plumes can be avoided. The risk is not catastrophic in the modern aviation safety framework. But the risk is also not zero, and the risk is increased by the federal monitoring gap. Right now, on the Alaska Peninsula, an American volcano with no recorded eruption history in human observation is showing the first geologic signs of magma rising beneath its summit cone. The federal seismometer monitoring that volcano is 17 miles east, attached to a different volcano. The satellite passes overhead twice a day. The infrasound network listens for sound. The lightning network watches for electrical discharge. The pilots and fishing vessel captains, who pass within visual range of the summit on clear days, continue to be, in significant part, the human eyes the federal government depends on to confirm whether the volcano has erupted. The clock is still running.